Okay, so this is the second of our Superlab examples, and we're going to be looking at the MPLS again and the RSVP. Now, before we can start configuring label switch paths on the RSVP, you have to make sure that MPLS is turned on. So we're using groups, as you can see here, with all interfaces and all units. We're going to be turning on the families ISO, INET6, MPLS. Obviously the ISO for the ISIS, because it's actually using the ISO packets for the hellos. That's literally the encapsulation. We want to turn on INET6, and then at the same time we want to enable family MPLS, because after all that's actually effectively going to change the encapsulation on the interface. We need to be inserting the MPLS header as a shim. So hence we need to make sure the family's on the interface, and then later on we need to make sure that within the protocol MPLS the interface is enabled. And the same thing with RSVP. There aren't very many commands that actually sit under the RSVP protocol. They tend to be interface related. So set protocol RSVP interface, and here is where we set the subscription so that it only uses half of the available bandwidth of that aggregate Ethernet. And of course up here we have the application of the groups, the apply groups for the interfaces that we want selected. And bear in mind, of course, that if you're configuring an LSI interface or a tunnel interface or some sort of unusual interface, that will also be grabbed by default here, so you may well need to have a few more exceptions. In this particular command here on this interface, it's actually a different router here, that's router 1. Most of these commands come from router 3. You can see that authentication is required, and we put the authentication key on. Okay, so at the heart of RSVP is its ability to do admin groups. The admin groups get configured with effectively a color or a label, and here we have the affinity number. Now that affinity number is going to go into the constrained shortest path first database, so that has to match across the network. So if gold here is 1, then obviously in the other routers gold should really be 1. If it wasn't, it would be the 1 that would be taken, not the label gold. So they really do have to match. And here, once those affinities and labels and admin groups have been defined, then we're down on the MPLS interface and we add those admin groups with the colors. So the interface numbers here are actually sort of self-explanatory. From 3 to 5 would be interface 4.35, from 3 to 4 would be interface 4.34, etc. All of the interfaces begin 4. So what happens to this extra information is that when the LSAs are sent in OSPF, or when the link state advertisements are sent in ISIS, this extra information, this admin group and the affinity information, is included on the link, and so it ends up in the topological database. And then what happens is you get a constrained shortest path first calculation, where effectively links that you were trying to avoid are pruned, and links that you're explicitly insisting on are used. So that then gets created into an explicit root object, which is a result of the SPF calculation, the constrained SPF calculation, and that is used by the source of the label switch path to signal the path. So the path goes out with the explicit root object. When it gets to the end, it's effectively turned around and the reservation is made on the routers on the way back. Okay, so we're now configuring a label switch path from router 1 to router 3, and as of course the LSPs are unidirectional, we're also configuring a label switch path from router 3 to router 1. Now the first thing to notice is that router 1 is running OSPF, and as such it's separated from the other routers, and its TED database won't be having the same information. So we're going to turn off constrained shortest path, because obviously that wouldn't be making any sense on this LSP. However, the section of the LSP beyond router 1 is going to be able to run fast reroute. So we can still have fast reroute running even if the CSPF is off. So just something to note here, that what we're doing in our examples as best as we can is that the LSP itself, we're putting the word to in the naming definition, and then the path on the LSP, like the primary or the secondary path, we're just removing that word to, so that at a glance you can see that this is a path that's operating on that LSP. So there's a few things we've been asked to do here. We've been asked for the route from router 1 to router 3 to take the shortest path. The way that we're going to do that is by including router 5 and router 3 itself loosely in the path. And what that will mean is, if, for example, the section or the segment from router 1 to router 5 was to go down, it can go via router 6 because this selection is loose, but the goal is that we go via router 5 to router 3 if we possibly can. But on the reverse path, the same thing. We have a loose selection for router 5 and router 1, and that fulfills the requirement for us to use literally the shortest path. Of course, we've got the CSPF off, and we've still got the fast-through route on. And so those are the two LSPs, router 1 to router 3 and router 3 to router 1.